Hello, our objective is to learn how a capacitor works through the construction of one of them. Well, to build a capacitor, we need a bottle of water, which might be plastic. We just need to cut a fragment of it. We need salt and water to put inside the fragment. We need one piece of aluminum, which would be the metal one, and another, like a cylinder of metal, which might be the metal too. All those elements summed are the whole capacitor.
We have to explain why does this capacitor generate capacitance. So, a capacitor is a device that stores energy due to an electric field. Capacitors in general have two conductors with a dielectric material in between, and this is the case of our capacitor. The electrics used were plastic, a plastic cup, and an electrolyte, which was water with salt. We also have to add that the electrolyte used can also be considered as a conductor.
Our capacitor has this form. The internal cylinder has a radius A with a positive charge, and the outside cylinder a radius B with a negative charge. In between these two cylinders, there's an electric field generated that makes that the energy is stored inside the capacitor.
We have a metal, and then we have another piece of metal, and it is all separated by a dielectric. And so when we connect a battery to our metals, one side on one metal and another side on the other metal, then the charge is stored in each of these metals, like this. The positive charge will go to one metal and the negative charge will go to another metal. So when we take out the battery, these charges will want to, the negative charges will want to go to the positive charges, but since they are disconnected, they no longer have a path to go. And so the circuit is no longer closed, and therefore our system generates capacitance, which means to store electric charge.
For this experiment, we researched the electric constant for the water and for the plastic, which are 80.1 and 2.25. First of all, we have to assume that we have two capacitors. First capacitor is going to be the glass. The first capacitance is 1.076 times 10 to the minus 8 farads, and this is the metal piece in the center, which has a bigger radius difference, and this is the second capacitance. As these two capacitors are in series, this is how we add them up, and the result is 10.71 times 10 to the minus 12 farads. But this is without considering that we have two dielectrics. This, as they are in series, we have to apply this formula, and this gives us a final capacitance of 23.43 times 10 to the minus 12 farads. And in comparison to the 90 times 10 to the minus 12 farads, we'll have a percentage error of 284%.
As we can see, our percentage error is really huge, almost 3 times the expected data, and this is because of several reasons. The first one is that we used undetermined kappa for our experiment. This is just the general value for water, and this is the general value for polyethylene. The second reason for our huge percentage error what are our theoretical values of the capacitance were considered inside a vacuum, and this is different from open air. Despite our huge percentage error, we can conclude that our experiment was a success since we were able to store charge in a device, which is the definition of a capacitance.